Yeah, so I met this woman the other day. I was talking to her, and she didn't seem too bright. She seemed pretty dim. So I told her she should go out and get a lamp. Yeah, that's the joke, 'cause she was dim, so she needed a lamp. Anyway, that's why I don't do stand-up. Today, we're building a dim bulb tester. Why would you want a dim bulb tester, you may ask? Sometimes you want to test out an old piece of electronics, but when you plug it in, one of the capacitors inside there might have gone bad, and now you have a direct short, which will let out the magic smoke and fry the rest of the device. To prevent that from happening, you can put a resistive load in line with the power, like a light bulb. Now when you power it on, the bulb will prevent a direct short, and the light bulb will glow to let you know that something is wrong. I made one of these a while back with just an old extension cord, a switch, and a lamp socket, but this isn't very elegant. I think we can do better. Now, this is not my idea. There's probably like 3 dozen other videos out there showing how to make this, but this is how I'm going to make it. You'll need a double gang electrical box. Make sure it's the kind that you can fit 2 outlets in. Then we'll need an outlet with a switch in it, and a regular outlet, some sort of power cord, an outlet to light bulb socket adapter, an incandescent light bulb, preferably clear so you can see the filament, a strain relief for the power cord, a wire nut for the ground wires. I'm going to use a Wago connector because I like these, the hardware to mount the outlets, and then optional is one of these plug-in voltmeters, and a cover plate. I'll put an Amazon link to all of this stuff in the video description. The only thing you need to get from Amazon is the voltmeter. Everything else you can likely get cheaper locally at a hardware store, or you might have some of these parts lying around already. Here's the wiring diagram for what we're going to build. I'll go over each of the connections individually. The hot wire from the power cord will connect to the switch. From here, the power will flow through the switch and into the hot side of the switched outlet. Now, the neutral side of the switched outlet, we are not going to connect the power cord to that. Instead, we're going to tie this to the hot side of the load outlet. This way, when we plug the bulb into the switched outlet, it will be wired in series with the hot to the load outlet. The neutral from the power cord then connects to the neutral of the load outlet, and all the grounds tie together. We'll plug the voltmeter into the top of the load outlet, and the device we want to test into the lower one. Let's get this thing assembled. Our first step is going to be to install the strain relief into the outlet box. To tighten the lock nut on this, I'm going to use this Gardner Bender lock nut wrench. These things are awesome. I'll try and do a full review of them later on, but I wired my whole shop with this thing. No more pounding on the nut with a screwdriver like a heathen. Then we'll feed the power cord through, and then we'll be ready to start making connections. Here's our switched outlet. I've already got a couple of pigtails connected to it for later. The connection for the incoming power from the power cord needs to go to the switch. When we look on the other side here, the 2 terminals have a little bridge connecting in between them. This sends the power from the switch to the outlet, so you do not want to connect anything to these 2 terminals, or you'll bypass the switch. And make sure to leave that little jumper guy in place. A top tip for connecting stranded wire to screw terminals is to twist the wire counterclockwise first. It's supposed to prevent the wire from fraying when you screw it down. It's something I picked up from an old-timer a while back, and usually forget to do. To put the hook in the wire, I just kind of bend it around an old screwdriver. You want the hook to go around the wire clockwise. This way it will kind of wrap itself around when you tighten it down. Now, I'm sure someone will complain about using stranded wire directly on screw terminals. It's fine. If it bothers you that much, you can crimp terminals onto the end of yours, but I'm not going to bother with that on mine. So that was our connection from the power cord to the switch on the switched outlet. Next, we have to connect our pigtail from what would normally be the neutral on the switched outlet to the hot on the load outlet. Same drill here, twist the wire counterclockwise, but make the hook shape go clockwise, and then tighten it down. Now we can flip the outlet around and connect the neutral. So we're going to take the neutral wire from the power cord and connect it to the neutral terminal on the load outlet. Once these connections are done, we can move on to the ground wires. I put a short pigtail for the ground on each outlet, and we'll connect them to the power cord ground with a WAGO connector. I love these connectors. You just put the wire in and then flip the lever down, and now it's locked in place. These are way easier to use than wire nuts, and since they're clear on the back side, you can see if the wire is in all the way after you flip the lever down. Now we can start putting everything together. I like this style of cover plate where the outlets mount directly to the cover plate. I know some people don't like that style. I don't care. Get whatever style you want. This is what I like. I also shorten the screws when using this type of plate. That's what those threaded holes are for in your wire stripper. Once the plate is mounted, we can go ahead and set it on top of the box, feeding the power cord through the strain relief, and I'll make sure to leave a little extra length inside in case I have to open it up again later. I won't have to undo the strain relief. Then I'll put the two screws in to secure the lid to the box, and then we'll tighten down the strain relief, and we're assembled. Let's test it out. The light bulb in the adapter plugs into the switched outlet. Now I'm using a 60 watt bulb here. There are other videos out there explaining better the logic around using different wattage bulbs. I don't fully understand it all myself, so I just go with a 60 watt. But you could also use 100, 200 watt, whatever you need for your application. Then we'll add the voltmeter to one of the load outlets. Now when I plug this in and flip the switch on, no, not really. It's fine. You can see the voltmeter powered up. Right now we're reading around 122, 123 volts. The light bulb is not glowing. Since the voltmeter is barely using any current, it's not putting any kind of a load on it. If we want to see the bulb glow, we can put another resistive load on it, like the Harbor Freight Hot Wife, which I reviewed in a previous video. You can see here when I turn the Hot Wife on, the bulb glows. So that bulb is now taking up some of the current that would have been going to the Hot Wife. If we take a look at the voltmeter, we've dropped down drastically to only 47 volts. If this was a vintage stereo I had plugged in, I'd know something was shorted out inside. Now you still have to figure out what is shorted out by yourself. It won't do that for you. But the dim bulb tester lets you know something is wrong, and it can prevent a direct short by letting that bulb take up the current so you don't fry the device further. It's a great thing to have if you do work on vintage electronics. Maybe it's something you need for your shop. Maybe not, but at least now you know how to make one. I'm still feeling bad about how I screwed up that joke earlier in the intro. I don't know. I bet Dice would have done a better job on that. So then I told her, you should go out and get a lamp. Oh! 'Cause she needed a lamp. Oh! Yeah, got a f***ing lamp for you right here. Oh! You